Hey everyone, it's Adam, and today we're going to be going over the blockchain. This video will probably be the longest in the series, just as more content dense, but I'm going to try to speed through it as much as possible because the content is not actually difficult, but there's more of it. So I think going faster will actually be beneficial in this sense, because after we go through this stuff, seeing it being used will actually be better for the understanding of the blockchain rather than just talking about it theoretically. So I have three links that I would consider prerequisites. The first one is How Does a Blockchain Work by Simply Explained. It's on YouTube. Really, really good video. It's only 6 minutes. It explains hash functions, the actual data structure of a blockchain, uh, and why it works. But how does Bitcoin actually work by 3 Blue 1 Brown? It's a really long video. I'd say 26 minutes, 30 minutes ish. It's content dense. It's technical in that after you watch this video, I would say you should have a thorough understanding of how Bitcoin and blockchain tech works. Um, you might have to watch it a couple times, but I do recommend watching it at least once. And then finally, Blockchain Facts, just an Investopedia link, has some good information that I'll reference probably throughout sometime in this course and in this video. So before we get into this, I thought I would just do a whiteboard of, let's go back here. I'd do a whiteboard just to explain two main concepts. The first one being a hash function, because it's widely used in the thing. And it's in the video if you did watch it, so this might be a little refresher, but if not, we'll just go through it quick anyways. So we have the idea of a hash function, and a hash function, I'll denote it by h, at some data. The hash function takes in data and it spits out a value. And this value is a fixed length. So we'll just say 8-bit value, for example, in this case. So you pass in a bunch of data and the hash function will output an 8-bit value. If you change this data, assuming that the hash function is collision resistant, you're going to get a different value to be outputted. And so in blockchain tech, you have I'm assuming you've watched the videos, you have a series of blocks that contain data. So this will be block one, which is also known as the genesis block. And within it, you'll have a couple transactions, let's say transaction. And then what the individual who mints this block is going to do, it's different for the genesis block, but we'll just say for a block, um, you're going to take this block and put it into its data form. So let's just say this is equal to some number. We'll call S. So we'll say this is equal to S. Then you're going to take the hash of S, and that'll be called, we'll call it S at H. And now this is the hash for this block's data. So when you go to mint, when an individual responsible for minting the additional block mints another block, we'll call this block 2, and it has transactions and such, what they need to do is they need to actually include the hash of the previous block in its data. So then they're going to take all this, we'll call this R. They're going to take the hash of R and it would output the R hash, and this is the hash of the second block. And the reason they do this is to preserve this thing called immutability. And it's one of the key concepts of a blockchain. And the idea is that if one were to ever change the contents of a block, it would invalidate the rest of the chain after that block. And what I mean by that is, let's say we were to change this transaction. Say that this transaction here was Bob sends Alice 2 Bitcoin. Let's say later Alice wants to be malicious and she wants to change this to 3 Bitcoin instead of 2. She wants to give herself one. If she were to do this, this would actually change S, change the hash of S accordingly, and now you have this value here. This value here is going to be different. I don't like that color. And if this value is different here, then that means this block is using a hash that no longer exists. And so this invalidates this as well. And then naturally, since every other block after this relies on the previous hash, the rest of the chain beyond where the change has occurred is not valid. And so that's how we end up with block chain immutability, sorry. And it all relies on this hash function. Understanding how the hash function works is kind of out of the scope of this course, but just the idea that if you have data, it produces a fixed length output, and if you change the input of that, it's going to change the output of the fixed length. Um, so let's look at what an example um, on Cardano would look like of a hash function. So here we have Cardano scan. We're going to look at this later in the course, but basically it's a blockchain explorer. It lets you visualize the blockchain. We can look at this recent block here. If we click on this block, we can actually see the block hash. So here we go. This is the hash of the block. Um, so this is one example of the output of a hash function would look like. You also have transaction hashes. Hashes are super useful in all of blockchain and computer science in general. So um, we'll leave it there for now. So let's go back to the PowerPoint and we'll go through this. So a blockchain is this database that is used to store data in a way that is secure, transparent, and potentially decentralized. Potentially because a blockchain does not necessarily have to be decentralized. All the ones that we'll be talking about will be. The chain's data is stored in sequential blocks, hence the name blockchain. So here in our little graph or picture here, we can see, I think this was taken from the first video in this link here. We have a block, we have its hash, we have a second block, the previous hash being the hash of the previous block, and so on. So if you were ever to be at a block in a given chain, you should be able to find the order of the blocks in sequence just by referencing the previous hash of all the blocks, and you'll eventually get to the genesis block, meaning the first block. These blocks are validated, cryptographically secured, and linked to each other in chronological order. So the linking is the hashing, cryptographically secured, we'll see what that means, and validated meaning the individuals can assure that the contents of the blocks are true, are valid rather. An important feature of blockchain is that it stores records immutably, which means that they cannot be changed, forged, deleted, as this will break the chain of records. I demonstrated that with hash functions. Um, Distributed when the blockchain is stored and maintained by many members rather than a single centralized authority. So this is the focus here. We have a distributed blockchain when we have a bunch of individuals who actually have this blockchain, the database, on their own computer locally, rather than having one entity have control over the database or the blockchain. And so when we reference Bitcoin, Ethereum, Cardano, Monero, like many of the big chains, we see that it's distributed and that anyone can download a copy of the chain. So this leads to the question, who can add a block to the chain? If we have it distributed and everyone has a copy of the chain, how can we add more data to the blockchain and get everyone to add it to their own? How do we confirm that what one's adding is true or is desired to be on the chain? If you have a single entity, it's pretty easy. They can just add a block or someone can submit it to them. They can validate it or add it themselves and just put it on the chain. And then everyone just references that data source as the truth. But when you have distributed, you need a way to ensure everyone has the same truth. And so this is the idea of consensus. Who gets to add a block? Do we all agree that they get to add a block? Is the block valid? Is the contents of the block valid? Um, so you have to decide who's going to produce a block. You have to decide if you have multiple people producing blocks at the same time, which version of the chain you're going to choose, and you have to verify that the produced block is valid. And so for Cardano, this is done using the Ouroboros protocol. Ouroboros is a massive white paper written by, I think we actually have this in the next slide. We'll reference it later, but we'll talk about Ouroboros in a bit. So first off, so the handle chain selection, the main idea that most, if not all, chains use is that you take the longest chain. Whatever version of the blockchain is the longest, you take that one to be the truth because that one would have had the most work put into it. That's the idea. There's no way you could produce a longer chain without having done an immense amount of work to get that chain. So that's the default. So the first mechanism for deciding who gets to add a block is called proof of work. It's a consensus mechanism in which computing power is used to verify and add blocks to the chain. And what does that mean by computing power? It means everyone runs their computer running this algorithm, and whoever can produce the output that there's an output that if you can produce it, you have the authority to mint a block or add a block to the chain. And this is done using hash functions as well, now that we know what hash functions are. So proof of work requires a computer to engage in hash functions until it arrives at an output with the correct minimum number of leading zeros. Not necessarily have to be the correct minimum number of leading zeros. It can be anything, whatever the solution is to the hash function. Whenever you arrive at that solution, um, you can you have the authority to mint the block, and you can prove it because the input to that block, if anyone were to hash it, they would result at the same output. And that's one of the properties of a hash function. So hash functions have a known computational infeasibility, have a computationally infeasible brute force runtime. Um, but if a pre-image was found, anyone could verify it with a single hash. What this means is that there is no better way to come to the solution of the problem than by just performing a bunch of hashes. Um, but and so you have to brute force it, meaning just compute a bunch of hashes, the most optimal way to find the solution. But if you were to have the input that produces a solution, you could verify that that does produce a correct solution almost instantaneously without any effort. So proof of work at scale requires huge amounts of energy, which only increases as more miners join the network. So everyone is trying to compute, and because you have this property of, let's go back here, because you have the property of adding the previous hash to your block, you actually, every time a new block is produced, you'd have to change the data that you're inputting into the hash function because it's required to be part of the block. So at the same time, everyone is, and also maybe some of the transactions you were putting in your block are in, you're like computing hash functions, someone else comes up with the solution, and they put one of the transactions you were putting in your data that in your block, they put it in theirs. So now you have to change the contents of your block. And so then you have to basically start over in computing the hash functions. So the idea is that everyone who is working on coming up with a solution to the proof of work problem is trying to find the same solution. And once one is found, everyone needs to collectively start over. Um, and so you have a massive amount of wasted energy in that a lot of the energy in computing the hash functions results, almost all the energy in computing hash functions results in incorrect solutions to the function. Um, and so the idea is then that this energy is wasted. Now, a lot of Bitcoiners may argue that it's not wasted because it is this energy that's being used that secures the network. Um, the price to even compute this many hashes, like the real life cost of computing that many hashes, is what gives some value to Bitcoin. And um, that's a different conversation altogether. But just the idea, I wanted to put that idea out there. Some people agree with that. And then the alternative to proof of work is proof of stake. And so it's also a consensus mechanism naturally. And instead of miners, we often use the term validators, or in Cardano, we have stake pool operators. Um, that's what we reference them a lot as. So a consensus mechanism in which a validator is granted the ability to add a block to the chain based on their number of staked tokens. So we haven't really talked about tokens yet, but um, these blockchains, when you have transactions, when you're, maybe go back to the whiteboard. Um, if you have, like, what do you put inside of a block, I guess, right? So the whole idea is that within a block, you have, it's a ledger, so you can say like Bob sends Alice and you send 3, but 3 of what, right? And then maybe since now Alice has 3, Alice can send Eve 2. Um, and so, but 2 of what? And so this is the idea behind cryptocurrencies, is that it's a currency of the ledger. So the currency exists within the blockchain itself, and that is the whole idea. Because if you have, this is explained really, really well actually in this video here about how does Bitcoin actually work, and they give an idea of being able to transact without actually settling in the real life and what that would look like. And then they come to what Bitcoin is. But we name this the currency that is being transacted to be Bitcoin, for example, in this case. But all the ledger is a list of transactions that prove you have the ability to transact in the future if you hold value that has been transacted to you, if that makes sense. And so why was I going into this? A validator is granted the ability to add a block to the chain based on their number of staked tokens. So these would be the tokens right here, right? These Bitcoin. In our case, it would be ADA for Cardano. That's the name of the token. And so in proof of stake, the more ADA you have, or in proof of stake, the more of the native token you have, the higher likelihood you're given of minting a block in a given period of time. So this is kind of a little confusing to say, but it'll make more sense when we talk about Ouroboros in a sec. So the next block writer, or the next validator, or minter, I guess you would call it, on the blockchain is selected at random, with higher odds being assigned to nodes with larger stake positions. So whoever gets to create the next block, it's random, but the more stake you have, the higher chance it's going to be you. And it's made as an alternative to proof of work to address energy consumption issues. And to become a validator, you must stake a specific number of coins. This is not always true, but in some instances it is. I'm not sure I even like this bullet point that I put here. Maybe I'd take it out if I could do it again, but the idea is that you put value into the network by owning some of the coins so that it's less likely you would want to act maliciously because you have value in the success of the network itself and success of the blockchain. And the more tokens you have, the less likely you are to act malicious because you have more at stake in a malicious action. That's the idea. You can look at this table here, but it's not too necessary. So briefly talk about the 51% attack. You can go more in depth in this and like search it up yourself if you want, but the gist of it is that if you control 51% of the resources within a proof of resource network, so 51% of the compute power, 51% of the staked token, you're able to block new transactions, change history, do whatever. So do whatever you have full power on the chain. So, and the idea is with proof of work that it would cost too much money to gather 51% of the computational resources, and it would cost too much to gather 51% of the native tokens. Um, Now these are big assumptions, first off, but so far seem true. So yeah, that's the gist of it. And the proof behind it is within those videos that I sent. They kind of explain the idea, but um, if you have more than 51% of the compute power, compute, you could recompute a block in history and then constantly produce more block. You can constantly produce the longest chain. And over time, you could actually, if you produce a block way back in history, you could theoretically you could be creating a new chain alongside the main chain and eventually surpass it. And then since the longest chain rule exists, your chain will become the true one. So Ouroboros is a proof of stake consensus protocol for Cardano. We referenced it 2 slides ago, and it was written by Agalos, a professor at the University of Edinburgh, and some other IOHK members. The white paper is linked if you want to go check it out. It's pretty robust, so I'm not going to go over it too much depth in this video. I think I'll make another video in the future, kind of going in depth into the white paper and explaining it all. It'll be a more technical video. This one's just high level idea. So again, protocol is guaranteed to be secure as long as the 51% attack is not, it's susceptible to 51% attack, but unless 51% of the stake as long as 51% of the stake is held by honest participants, it's good. And it's achieved through random leader selection, apparently. One can participate through operating a stake pool or delegating your stake to a stake pool. So you can either run your own stake pool, like stake your own ADA and be the individual to validate blocks or mint blocks, add blocks to the chain, or you can delegate your stake to a stake pool operator. And there's thousands of them on Cardano. Most people would just delegate. And rewards are earned by participating in these activities. So you're actually ensuring the decentralization of the chain when you delegate and when you operate a stake pool, and you are given rewards for this. And where do the rewards come from? Um, Maybe I should have referenced this before, now that I think about it, but when you mint a block in proof of work or proof of stake, you are financially incentivized. You get to add at the end of this list of transactions like a nobody, I guess, underscore gives me 2.5 Bitcoin, we'll say. And so where is this coming from? This is coming from the total supply. Um, so you have a total supply, so in Bitcoin is 21 million. And then you have the amount of Bitcoin in circulation, which is a subset of this. I don't know what it actually is, probably like 19 million, maybe somewhere around there. And so there's 2 million that have not been minted yet. And every time a block is created, you end up minting more. And the same is true with Cardano. Um, and then additionally, there's transaction fees that also get created. So between transaction fees and um, monetary expansion, I think I have this listed here. Between transaction fees and monetary expansion, you get rewards for delegating or operating your own stake pool. And by delegating, you get a share of the rewards. You get a percentage of it. So Ouroboros is split up into slots and epics. So an epic is 5 days in the current implementation of Ouroboros, and then right here an epic is 5 days, and there is a slot every second. So you have 432,000 slots within an epic, and in any slot, 0 or more block producing nodes might be nominated to be the slot leader. So based off of your amount of stake that you've accumulated through delegation and through your own pledge, your likelihood of being nominated increases the more stake you have. And based off the protocol parameters, roughly one node is expected to be nominated every 20 seconds. But it's possible that 2 nodes can be nominated for the same slot, um, or one every 20 slots. Maybe we should use slots instead of seconds. But yeah, theoretically, more than one node could be nominated every slot, and sometimes that does occur, and we call this a slot battle. And there's a tie-breaking mechanism that's widely discussed currently, and it's a pretty big topic at the moment in the Cardano ecosystem. So we'll let that be, but the idea is that there is a tiebreaker in case that does happen. So one gets discarded and one candidate gets to put the block in the chain. So Praus, there's different flavors of Ouroboros, if you will. Praus divides time into epics, and each Cardano epic consists of a number of slots. So yeah, we talked about that. A nice part about Ouroboros is that it has unlock staking. So in some chains, you have to stake your your native asset, your digital asset, native token, whatever you want to call it, and you're actually unable to transact with it while you're participating in the staking. In Cardano, you have these things called delegation snapshots, where at the beginning of an epic, so every 5 days, there is a snapshot taken on where you're currently staking to. And that is the amount of stake that you're um, given or that you hold for the next 5 days until the next snapshot that occurs. So you're allowed to, during those 5 days, you're allowed to transact and do whatever with your stake because it's unlocked. And whatever your current stake is and wherever you're staking during the next snapshot, that'll be your stake for the next epic, for the next 5 days, and so on. There's actually a 2 epic delay in Cardano. So this helps because then you're able to and like see if there's any malicious actors and change. You have time to change who you're delegating to and such. But nonetheless, um, delegation snapshots allow for unlock staking in Cardano. It's a big plus for Cardano. I'm not sure if any other chain has that. So for each slot, a stake pool is assigned as a slot leader. Not necessarily, not each slot, but for slots, stake pools are assigned as a slot leader and is rewarded for adding a block to the chain. Individuals may delegate their stake to a specific stake pool, increasing its chance of being selected as a slot leader and share in the stake pool's rewards. Yeah. Awesome. So the last slide we're going to talk about is Ada Lovelace and cryptocurrencies. So naturally, going back to the whiteboard, you have to incentivize individuals to create blocks, to use your compute power, or to run a node in the first place to mint a block. And how do you do this? You do this with cryptocurrencies. Cryptocurrency just being a native asset on the chain, so Bitcoin. Um, the the name for the asset that is being transacted upon the ledger. That is a cryptocurrency. In Cardano, the cryptocurrency is named after Ada Lovelace. Ada Lovelace being an English mathematician, considered to be the first computer programmer. So cryptocurrency is a digital asset which is stored on the ledger and is designed to serve as a medium of exchange. blockchain ledgers serve as the underlying technology for cryptocurrency creation and transfer. Kind of self-explanatory. So each blockchain has its own underlying cryptocurrency, and it's used to pay fees and reward block producers. So there's a lot of speculation that goes into price of cryptocurrencies, and a lot of people know about that, but not a lot of people actually understand the tech that underlies it all. Um, and I kind of think of it like without speculate like to avoid speculation, kind of how I think of it is if people want to add transactions to the chain, they need the native token to pay the transaction fee. And so the more people want to add transactions to the chain, the more desired the native token is, and thus the price is going to go up. It's all about supply and demand. And where does the demand come? The demand comes from individuals wanting to add data to the chain and interact with the chain. So if somebody wanted to increase the price of the cryptocurrency, they would want to increase the demand for transacting on the chain. And so you see that a lot with dApps and different NFT gaming, things like that on they call Web3. That whole idea is to try to increase demand on the blockchain. Um, so yeah, ADA is the native currency of Cardano blockchain, and it's split. It can be split evenly into a million Lovelace. So one ADA is a million Lovelace. Um, Most of the time, you don't actually end up referring to Lovelace when just as a user of the chain. It's a pretty small denomination, and so you normally talk in terms of ADA. Um, Cardano also supports the creation of native tokens, digital assets that are created for specific purposes. This is not unique to Cardano. Other chains do this. Ethereum, for example. Um, you create digital assets that are then able to be transacted with on the chain. So in an ADA block, you can imagine you have a big transaction here, and you have Bob gives Alice 3 ADA, but they could also give 3 Hosky. And what is Hosky? Hosky would be a native asset that was minted or issued by an entity on the chain, by an account on the chain. Um, and you're allowed to do this. Anyone can do this, and then you can transact with them as well. And so the nice part about this is that you can imagine businesses, governments, whoever, issuing their own tokens. Um, and then, yeah, you can theoretically have your own cryptocurrency, whoever you are, government, business, and deal with it how you see fit. Um, and so a token can be fungible, meaning exchangeable, interchangeable. ADA, for example, is fungible, or it can be non-fungible. So you have NFTs, by definition, non-fungible tokens, IDs, things like that. And they can act as a payment unit, reward, trading asset, information holder, whatever. So you can attach metadata to transactions as well, which allows you to do tons and tons of things. For example, an NFT. So that's the end of this video. Hopefully that helped a lot for your understanding of blockchain. I know it was long and tedious. We did talk about a lot. Maybe just to go over quickly, we talked about hash functions. Highly recommend watching these videos. Your understanding will increase drastically from these videos. Um, we talked about immutability of the blockchain and linking blocks. We talked about the idea of who gets to add a block to the chain and the different mechanisms to prove who can add a block to the chain. We talked about an attack vector for chains and its resistance being expense to actually perform this attack. We talked about Ouroboros, which is the proof of stake protocol that Cardano uses. Um, we talked about how it's broken down into epochs and slots, and how an individual is granted the right to produce a block based on the amount of stake that they currently hold, and then block producers are rewarded with transaction fees and with monetary expansion, which is the idea that you have a finite amount of currency, of cryptocurrency in circulation. Sorry, a cryptocurrency total, and then you have a subset of that in circulation, and you eventually get up to this um, total amount. It looks like the graph over time. This is time, and this is time, and this is amount in circulation. You end up having like this thing that looks like this. So it's constantly, continuously increasing, but it never actually gets to the value, which is in Bitcoin's case 21 million. Um, and that was the gist of it. We talked about the fact that you take the longest chain as the general rule for which chain to trust, and then we talked about ADA, the native asset of the Cardano blockchain. If you have any questions, go ahead and leave them in the comments. I'll try to get back to you as quick as possible. Thanks for watching. Hey everyone, just going to add something onto the end of this video really quick. I made a comment about the native tokens, like around 26 videos in the blockchain video, and how they're also the same on Ethereum. That was wrong. I just said it really quickly, wasn't thinking too hard about it. Cardano supports native tokens, which basically treats all tokens the same as the native currency ADA would be treated on the blockchain, and it does not require smart contracts for the usage of them. Um, they can be used in smart contracts, but they are treated just like native token, like ADA would be a native token. So that is a unique value proposition and is not the same on Ethereum. Um, Additionally, I thought I'd make a remark on back here on decentralization in a distributed network. In watching, I don't know if I made it clear enough. Distributed networks are just networks where the underlying data is in multiple locations. So if everybody has a copy of the blockchain, it's distributed. Whereas decentralization, and this is a key difference, is being able to distribute block production. So if you have a centralized blockchain, that's kind of a vague term. You could mean centralization in terms of um, block production. So who gets to add a block to the chain? Maybe that's just one individual, and that would be a centralized um, chain, in my opinion. Or if it's the location of the chain is in one spot, that's also centralized. Um, but in terms of blockchains, we typically say decentralization in terms of block production. So if you have a bunch of different people in consensus that get to add blocks to the chain, um, and people get to, in proof of stake, for example, allocate their stake to decide who gets to add the block, or allocate their compute power to decide who gets to add the block, or to add the block themselves, rather, you would deem that decentralized rather than one individual or centralized authority being the only person who can add a block to the chain. So yeah, decentralization versus a distributed network, two different things. Important that they're different. And then also native assets on Cardano, or native tokens, whatever you want to call them. A unique value proposition for Cardano, not the same on Ethereum. Not the same as the ERC20 token. So okay, yep, thanks.